So provided two angles supplementary here, A and D, and then provided an additional set of supplementary angles, A and H, okay? If they both pairings, I guess, contain the same angle here, angle A, then these two will always be congruent, okay? And that is seen in what we call the congruent supplements theorem, okay? And it says if two angles are supplements of the same angle or to the same angle, or two congruent angles, then the two angles you started with are congruent, okay? So if two angles are supplements to the same angle, then the two angles you started with are congruent, okay? What they might ask us to do is prove this, okay? So I want to go through the if part. Okay, remember the if part is always the given, and the then part is always the proof, okay? So the first part we're going to do is we're going to start off with two angle supplements of the same angle. Two angle supplements of the same angle. That's kind of maybe a hard statement to write down with specific angles, okay? But it says two angles are supplements of the same angle. So they write angle 1 and angle 3 are supplements, angle 2 and angle 3 are supplements, okay? So hopefully you see that angle 3 is that same angle that they were talking about here, right? It's consistent in both phrases. And 1 and 2 then are the two angles that are supplements of 3. Is that doable? All right. So a lot of times when you have a theorem and you want to prove it, and they don't give you the proved statement or the given statement and the proved statement, you have to take your if and rewrite it with specific objects. In this case, our angles, and they have to these objects that you write in here in the if have to maintain the same arguments, the same information that you found in the theorem. Does that make sense? And that tends to be something that people struggle with. We'll do it a couple more times a day. But that's the if part. The then part, I think, is a little bit easier. It says, then the two angles are congruent. Well, the two angles were 1 and 2, so then we see 1 and 2 congruent over here. Okay? That's then how we transition into this, and we're going to now write the proof for that theorem. Okay? And my hopes are is that when we get done, we can look back and make a connection with this and something else that we've already done. So the first thing I want to do, I'm going to type these in because my handwriting is kind of bad. I'm just going to say angle 1 and angle 3 are supplementary. Spelling's bad too. And that's going to be given. Okay, now the same logic says that angle 3 and angle 2 are supplementary as well. Okay, so that's all my given information. All right, now we always talk about once you write your given down, you go back to your picture and you draw in the information in your picture. There's really no way to draw in supplementary into a picture. Okay, really the only time we're going to go to a picture and draw something in the picture is if it's a congruent statement that we find from our given. Okay, so we jump straight to vocabulary, and hopefully you realize that that word and that word are your vocabulary from this problem, right? If we were to search the back of the book, go to the glossary, look up supplementary, and what would it tell us about supplementary angle? See? They're angles that add to 180. So for us, the angles are 1 and 3. So I'm going to write measure of angle 1 plus measure of angle 3 equals 180. And I'm going to say the same thing then for measure of angle 2 plus the measure of angle 3 equals 180. All right, and that's definition of supplementary angles. Okay. Now, we've done this before. Hopefully you start to recognize patterns that we've seen before. Do both these things right here. So let me get the highlighter to work. Are both those 180? And is 180 the same thing both times? So what does that tell me I can do with those two things. If these are both equal to 180, then these two things are what? They're equal, okay? And that's a pattern that we've seen consistently in some of the previous proofs. So I'm going to say now that measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3. Okay? And the argument there is that I have taken this 180, okay, which we have shown in the bottom line here, that 180 is the same thing as 2 plus 3, right? So I'm taking line 3 here is the exact same thing as line 2, but where in the first line of line 2. So I'm rewriting that phrase right there, 1 plus 3, so you got 1 plus 3, is equal to, now previously it was 180, but now we know that 180 can be redefined or restated as 2 plus 3, right? So when I pick out that 180 right there and replace it with this 2 plus 3, what is that property called when I do that replacement? I heard it. Substitution. Okay. Now in this case, it also works this way, because I could say, and I'm gonna come down. Don't write this down right now. But could I say that measure of angle 1 plus measure of angle 3 equaled 180? But could I then said 180 equals the measure of angle 2 plus measure of angle 3? And now we've got, in this situation, this would have been an A idea here, or an A object. This is B. This is B. And that would have been C, right? So we got the idea, if A equals B and B equals C, then we could have made this argument here, which says A equals C, right? What property is that when A equals B, then B equals C, then A equals C? Transitive property. So that is an option here. If you would have written transitive, that is perfectly fine. Substitution or the transitive property exists. Step 4 then, okay, here's the idea. Once we start doing substitution, and now we get an equation, we like to do algebra with that equation, okay? We're either going to add stuff or subtract stuff, okay? Now, if I don't really know what I would add to both sides. This up here, we don't have anything that is being mentioned in steps 1 and 2. We don't have anything being mentioned that we could just add to it, okay? So we probably want to subtract, okay? And I look at this, another way to remind myself that I probably do want to subtract in step 3 is that there is an object that is on both sides. What is that object that is on both sides? Yeah, measurement of angle 3. I call it algebra, but it's really a number, right? Okay, whatever the degree is for angle 3 is on the left-hand side, whatever the degree for angle 3 is on the right-hand side. So do they cancel each other out if one's on the left-hand side and one's on the right-hand side of the equation? Yeah. Okay, so let's just get rid of them. All right, and here's something we have to do every time. Before I actually get rid of them, I'm going to tell everybody that what I'm about to get rid of is actually the same thing on both sides. Okay, and so I just before I do that subtraction, we're saying measure of angle 3. The value on the left, it's arbitrary value, we don't know what it is, it's hidden behind that symbol measure of angle 3. It's the exact same amount as the value hidden behind the arbitrary symbol measure of angle 3 on the right-hand side. Is that doable? What's the property when I say something is equal to itself, something's congruent to itself? It's reflexive. Good. Okay, so that's the reflexive property. And then again, that just becomes something that's a technical point, I think. And it's right now it's of equality. But it's just something that we like to write in to tell everybody that was reading our proof that we do know that we can do the subtraction because it's the same amount from both sides. It is a property that the end of course exam kind of expects you to use. We will use it a lot more when we start getting to chapters 3 and 4 with congruency and not so much equality. But that is a necessary thing to do. Now, when I wipe Let's see here. When I wipe away 3 from this side and 3 from this side, what would it leave me with? Yeah, measure of angle 1 equals measure of angle 2, right? So we want to actually do that subtraction and write down what we're left with. Measure of angle 1 equals measure of angle 2. And we know that those are equal because we know we were allowed to get rid of angle 3 from both sides. And getting rid of something is what operation? Subtraction. Okay. So now I have measurement of angle 1 and equal to measure of angle 2. So I've got 2 degrees, two numerical values that represent a property or a characteristic of an angle. And it's the only value that distinguishes angles. Okay, it's the only characteristic that we're interested in numerically about an angle, and they're equal. So that tells me, in the sense that those numbers are equal, it tells me the actual shapes are what to one another? Congruent. Now I don't have a congruent symbol here, so I guess I could do that. Oh, no, we'll turn it off. And when I go from step 5 to step 6, when I go from equality to congruency, what is that property? Definition of congruency. Okay. Now my hope is you still have your notes from Friday. Okay. And I want you to sift that real quick for your notes from Friday. Okay. And I'm actually going to, let me copy that, and we'll go back. And I want to look at the proof that we did for the vertical angles theorem on Friday. Okay, so I just cut and pasted what we just did, okay, over here on the right. And these are at least the statements that you started with on Friday. And let's just compare them. Is number one's different, right? Vertical angles. But when I see number 2 here, 1 and 2 are supplementary, 2 and 3 are supplementary. Okay? Now I know they're referencing different labels, different names for the angles, but is that a similar idea as statement 2 here on the left-hand side, a similar statement as what we got there? Okay? Then, is that statement there similar to that statement there? And then that statement followed, which is similar to that, right? We did subtraction and got that. Did subtraction over here and got that. Okay? Yeah, on Friday, I think we put like step 4.5 in there, reflexive property, right? Okay. And then we went 1 equal to 3, got me 1 congruent to 3, and over here 1 equal to 2, got me 1 congruent to 2. The proofs are identical, aren't they? Okay. We have already, and that's what I'm hoping you guys kind of recognize as we go through these, and hopefully build a database of proofs in your notes, because it's going to be all the time that you see, I think I've done something similar to this. Let me skip back through my notes and make comparisons, and that might allow me to kind of progress through the current proof that I'm on. Does that make sense? And if you just recognize those patterns 2, 3, 4 times, then at any point after that you see it, you'll probably know it, and you'll be able to address it pretty easily. But it's very consistent, very regular that you start to see patterns like that throughout the course. And like I said, a lot of times, of the 150, 200 proofs that we do in a year, you can probably categorize that down into 5, 6 different proofs. Okay, this is kind of like one of those proofs. Okay, we get to chapter 4. Chapter 4 is really one type of proof. It will do all. That's where we'll hit proofs the heaviest is in chapter 4, but it's simply just one type of proof in that entire chapter. If we start to recognize that. They become very simple. When we get to slide 10 here, same idea. Okay, whenever we talk about supplements in this course, it's probably a good idea to talk about their partner, which is complements, right? Whenever you talk about supplements, you usually talk about complements. this theorem here is exactly the same thing the last theorem said, but except for being supplementary, and then we're going to say they're complementary. Okay, so 180 changes to 90. Okay, so the only thing in the proof, sorry, the theorem, the only thing in the proof that changed was that word there. Went from supplements to complements. So when I get into the proof of this theorem, the only thing that's going to change is the word supplements. It's going to change to complements. And now in the list of statements, okay, this list of statements, those numbers there are going to change to what? They're going to change to 90. And that is the only thing that is different about the proof of this theorem and the proof of the complements. Okay? So if you understand one of those theorems, the hope is you understand the other one. And that's what happens a lot of times with whenever we have a theorem about supplements. There is usually a corresponding theorem that goes with complements as well. So if two angles are complements of the same angle, then they're congruent to one another. So we'll skip that proof. Okay. Something that you guys probably already know, I think it's pretty straightforward, pretty elementary, is that if I give every one of you a right angle, and we take out any two of those right angles and they be congruent, we can do that all the time, right? Every right angle that you draw is going to be congruent to any other right angle that you ever draw. Okay. It's actually a very, very important theorem. It might not seem very difficult to think about, okay, but it is a proof that I want to go through, okay. When they start you off, it says all right angles are congruent. All right angles are congruent. What might happen on a test, and of course exam, I don't know, so just some place where they ask you to do a proof of a theorem, they might just say, hey, section, what was this theorem? It's 2 point, out of our textbook, it's 2.4, okay? So if I'm in, this happens a lot, and I can show you some textbooks later that show this, but it might be like question 20 in your homework. It might say, reference back to theorem 2.4 and prove theorem 2.4, okay? They don't give you anything in regards to the given information, they don't give you anything in regards to the prove information, and the theorem is kind of poorly written, okay? It says a lot with as many or as minimal amount of words as possible, but it's not really written in a format that allows us to develop our given and our proof. Okay. So first thing we want to do is take that statement and write it as a if-then statement. Okay. It says all right angles are congruent. Well, that means if I have two angles that are right angles, they should be congruent, right? Or if I have three angles that are right angles, then they should be congruent. Or four right angles that are angles that are right angles, they should be congruent. So the easiest thing for us to do is just to choose two angles, okay? So I rewrite this, say, if two angles are right angles, then they are congruent, okay? Now that two, we are not specifying that we're only going to look at two, okay? Inside the proof, we will look at just two, but that two is an arbitrary two, so it could be any two out of the collection of all. Does that make sense? Okay? So that word two and that word all are saying the same thing for us. Okay. So now, kind of what we talked about last week, my given is the if part. So I'm going to write two angles are right angles. My prove then is what's left over. It's the then part. It's the conclusion. So they are congruent. Okay. Now that's kind of maybe the first way, the first kind of rough draft that you would write of your given and your proof. But if you think about the way we do proofs, that's going to be a really hard procedure to do if I leave it with that given and that prove. Because what are my two angles? Okay, what are they? Okay, how can I talk about them? Does that make sense? So I want to specify some specific angles. So instead of two angles are right angles, I'm going to say angle 1 and angle 2 are right angles. Okay? Or if you want to say angle A and angle B, or you want to say angle 4 and angle 9, it doesn't matter. Just name two angles. Let's say two angles are right angles. Now the prove is going to say they are congruent. So they being angle 1 and angle 2. So I'm going to say angle 1 is congruent to angle 2. Remember, I need my congruent symbol there. But now I've developed a starting point for my proof. Now I know what my given information is. And I'm going to say angle 1 and angle 2 are right angles. And that's my given. Okay. Now there's a vocabulary word there, right? What's that vocabulary word? If I were to look in the back of the book, what's that vocabulary word tell? What's the vocabulary word first? What is that? Right angles. So if we search through glossary, it's going to say right angles are angles that what? Have a measurement of 90 degrees. So I'm going to write down what that means for us. Since 1 is a right angle, it means directly that the measurement of angle 1 is 90. Okay, come on. There we go. It is also going to tell me that the measure of angle 2 is 90. And we got that from a vocabulary word. We knew from the glossary that's the information. So we're going to write definition of right angles. All right. Now here's the idea. If I have measure of angle 1 equals 90, can I take that 90 right there and replace it with that measure of angle 1? Or vice versa? Okay. Wherever I see maybe 90 up here, I can replace it with measure of angle 2, right? Those things are equal. So I'm going to say measure of angle 1 is equal to measure of angle 2. My reasoning there is substitution, and this could also be transitive for the reason, maybe put this in, we could say, like, if I had measure of angle 1 is equal to 90, and 90 is equal to measure of angle 2, make that smaller, there we go. If 1 was equal to 90 and 90 was equal to 2, does that get me from 1 straight to 2? Okay, so it could have been a transitive property if I use that logic. Now, if 1 and 2 is measurements, so the number that's associated with those angles, and that number being a degree, if they're the same, what's it tell me about those two angles as shapes? Angle 1 and angle 2 are what to one another? They're congruent. Okay. Put your congruent symbol in there. But that's going to be, if I go from equality to congruence, that's definition of congruency. Okay. Now my hope is, again, that you recognize that this proof, though it uses different definitions, okay, is still extremely similar. Let's see if I still have it. Let's cut and paste here. No. There we go. It's still extremely similar to this proof. Okay? Turn your phones off, please. If I have 180 and 180 here, right? Okay, then we took these two parts. Let's see here. We took those two parts and set them equal to each other because these 180s were the same, right? Well, now these 90s are the same. So I'm going to set this stuff over here equal to one another. Now, it's not a sum anymore. It makes it a little bit easier if it's not a sum. Okay? But the procedure is still kind of the same, right? If I set them equal to each other, now I get to this step here. Okay? Which before it was this step and I had to do subtraction. But now because there's no sums on either side, I don't have to do that subtraction. But the procedure, the process, the concept's the same. Is that all right? Okay? Yeah. Huh? Is that yours? Yeah. Now I know your mom is the only one texting you. Yeah. I know. He doesn't have any friends that are going to be texting. It's going to be his mom, all right? All right, so, again, trying to not only learn some geometry facts, and the fact that all right angles are congruent and that kind of stuff. What I want to get at is that when we do proofs, yes, they might be difficult and somewhat confusing at times, but if you understand a small collection of them, you can write them down in your notes and revisit those. they help you build and create other ones. Okay, and they're very pattern-based. And my hope is that you realize you should not be starting from scratch every single time you see a new proof. This idea, okay, we'll kind of walk through this as if two angles are congruent and supplementary, then each angle is a right angle. Think about this. If they're supplementary, what are they going to add up to? Okay, 180. If they're congruent, they both have to be the same, right? So I take that 180 and I divide it by what? 2, and that gets me one angle to be what? 90. That mean it's a right angle? All right, so that logic that we just went through right there, and you told me all the answers to that logic is the proof. We just now have to articulate it. We have to put it down in math, okay? So just real quick here, go through this proof, and we'll start with their if and their then stuff. So we'll use their angle 1, congruent to angle 2, and that kind of stuff. So angle 1 equals angle 2. And then I'm going to write that angle 1 and angle 2 are supplements. All right. Cam, what's it mean for two angles to be supplementary? Yeah. Okay, so add them up, set them equal 180. So step 2 is definition of supplementary angles. Okay. This is kind of a key point here. You write that down. You start thinking, oh, that's a similar question that we've done. When we had two angles that are supplementary, usually we had another pair of angles that were supplementary, right? We go back to the vertical angles theorem. We go back to the congruent supplements theorem. There were two lines like number 2, right? Okay. Then we had angle 2 and angle 3 equals 180. This one doesn't provide that. Okay. So when this one doesn't provide it, two separate sets of angles being supplementary, chances are you're going to have to do direct substitution. Okay. So chances are we're probably going to replace 1 with something or replace 2 with something. Okay. And that replacement comes from that phrase right there. Now those are shapes, so we got to do a little bit of altering, okay? But those are shapes, and if those are shapes, shouldn't their angle measurements be the same? So I'm going to write, and that's definition of congruency. All right, now what I want to talk about is that those two steps, 2 and 3, they're actually what we refer as independent statements to one another, okay? Which means I could have put statement 3 in statement 2's location and statement 2 in statement 3's location, right? Dependence means that you are affected by something else, right? Okay. Well, measure of angle 1 equals measure of angle 2 is not affected by 1 plus 2 equals 180. And vice versa, 1 plus 2 equals 180 is not affected by angle 1 equaling angle 2. Okay. What I do want to make sure we understand is that statement number 2 is dependent on statement number 1, right? I can't make the statement that those two angles after 180 until I know they were supplementary in statement number 1. Does that make sense? So there's an importance or an important concept of what we call dependence and independence inside proofs, and that's an idea that allows maybe your neighbor's proof to be a little bit different than your proof, because those two things could be flip-flopped. Okay. Now what I'm going to do is, if I got measure of angle 1 equals measure of angle 2, can I come up here and just replace 1 with 2 right there? So statement number 4, I'm going to write as measure of angle 2 plus measure of angle 2 equals 180. And that's substitution. Okay? Statement 2 and 4. Okay? I got 4 by rewriting 2. But instead of writing number 1, angle number 1, I wrote it as angle number 2 because they're the same here in number 3. Does that make sense? Now this step is dependent on all 3 of those. Okay? So step 4 cannot be in between 2 and 3. It can't be in between 1 and 2. It has to become after all 3 of those statements were made. Okay? So it has dependence on those 3 statements. Now we can do some algebra. If I've got that fact, if I've got measure of angle 2 plus measure of angle 2 equals 180, and remember, this is a number, right? This is an unknown number. Okay? Well, if I have an unknown number, isn't that kind of like a symbol representing an unknown number? Isn't that a variable? So if I had that as like x, and that was x, what would you write x plus x as? 2x. So now we have measure of angle 2, so let's write that as 2 measure angle 2's. Is that okay? Because when I write 2x, I'm referring to that as 2 times x, right? So 2 times the measure of angle 2. All right, now however you want to write this, you got some options. You can say it's simplifying. Okay, you can say that it's combining like terms. Okay, but that's what we're looking for there in that particular step. Okay. Now, if I had like 2x equals 180, you would solve for x by what? Dividing by 2, right? Well, let's, this is my symbol. This is my variable now. Let's solve for it. So divide both sides by 2. Measure of angle 2 then is equal to 90. So that was division. It's a property of equality. Now, if angle 2 is 90 degrees, what kind of angle is it?
Right.
Angle 2 is a right angle. And that is why? How do you know that's a right angle? Definition of a right angle. And now you're saying because 90 degrees is a right angle, right? So you're telling me the phrase in the back of the book, which is fine if we want to write that phrase out, but a lot of our phrases become very long, and we don't necessarily want to do that, so we just reference the definition. Now, that's all we've done is shown that angle 2 is a right angle, right? Now, there's a couple of different things we could do here. We now know angle 2 is a right angle, but in the beginning we were told 1 and 2 are congruent, right? So we could say then, because angle 2 and angle 1 are congruent, angle 2 is a right angle, angle 1 has to be a right angle as well. Does that make sense? Okay. Another, probably more precise, more accurate, more maybe appropriate procedure is at this step right here, we would come maybe, let's see here, I'll just cut this out. You don't have to write this down. But maybe the most appropriate thing to do would to be go through the exact same process again. Up here, we did the substitution, so we're left with the measure of angle 2. We would probably want to go through the substitution again, but now do the other substitution. Replace 2 with 1, and now we get this, and now we would get that, and now angle 1 is a right angle. So now we've proven that angle 2 is a right angle and angle 1 is a right angle. Does that kind of make sense? Okay. That's probably the most accurate way of doing it. Okay. But understand that that stuff there in red is exactly the same thing that we have up here in black. And if we just write out a short statement that says, because I've already shown that angle 2 is a right angle, and I know angle 2 and angle 1 are congruent, I know angle 1 is a right angle, that is sufficient. Okay. But please understand that if we were to stop at 7, angle 2 is a right angle, that really doesn't prove this conclusion that each is a right angle. We've only shown that 1 is a right angle. We need to show both. Just little technicalities within proofs that we come across every once in a while. I want to do one of these. Let's do this one. Because in your homework, there are some questions that ask you to deal with things like this. And what I want you guys to realize is that, and we talked about this on Friday, when you are tasked with finding x's or y's or angle measurements, you might not be able to directly find them right away. For instance, if I were to ask you to find this angle up there, you can't do that right away. You've got to do some other stuff. Okay. You know, it's kind of like if you ever got on an airplane, you want to go straight from, Detroit to Milan, Italy, okay? You might have to stop over in Atlanta, you might have to stop over in Sicily, and then fly to Milan, right? You might have to do kind of layover type stuff. And it's the same idea here. We might have to go a couple different routes before we can get to where we want to go, okay? To our final solution. But in order to do that, you need to be able to be successful. And it gets a whole lot more difficult later on in the year once we've learned a lot more information. But you want to answer this in regards to the context of the problem. Look at all the different relationships you know. Okay? I'm going to kind of guide you on this one to see maybe some relationships that are good, some that are maybe bad, and then maybe some of these bad ones that we initially start off with, how we could still solve using those. Okay? What would be the relation that you know about those two angles right there? Supplementary. Okay? So I can add them together and set them equal to 180, correct? So I'm just going to do some combining the like terms real quick. So I got 3x plus 5x gives me 8x. I'll have a 4y plus 4 equals, plus 8, I guess, equals 180, right? Okay. What's bad about that equation? What do we not like about that equation? X and y. It's got two variables, right? Okay. The idea is that whenever you have two variables, you could solve for one of those variables. So you could go through all the words and say x is equal to all this stuff on the other side, but all that stuff on the other side will still have a y in it. Does that make sense? So you could say you can isolate this x right there, move the 4y over, move the 8 over, divide everything by 8, and you have x is equal to something, but it's still got a y over there. Okay. So when you have an equation that has two variables, what you need is another equation that has the exact same two variables. So if I go up and look at this problem, is that set of red angles another relationship that I should know to be true about this problem? Okay. So could I say 10x plus 4y minus 20 is equal to 180? Make sense? Okay. So that could be the approach. Maybe somebody throughout the entire lesson gained those two pieces of information, and those are two equations that are true. And we should be able to use them together to solve. Okay? Does anybody see an equation up there that might be a little bit easier? Okay. Yeah, these two angles should be vertical angles, right? Now, why does that make that an easier equation? 3x plus 8 is equal to 5x minus 20. How many variables do you have? Well, there's two, so you see x twice, right? But it's the same x value, so you only have one variable. And that's easier to solve. So the idea is that when you're doing these problems, and any problems throughout mathematics, is you start writing your information down, but don't just start blindly doing it. Okay? So if I start blindly doing the work, I'm going to solve these two equations. It's going to be a task to solve these. We'll do it. But it's going to be a task to solve these. Where if I do this one, that's so much easier. Okay? If I solve this one, I'll move the 3x over. I'll move the 20 over to this side, so I get 28. Divide both sides by 2, x is 14, right? Very straightforward, very easy to find x. Okay? But now, let's say I never came up with that green one, and I want to deal with these blue and red ones. If you remember from last year, when you have equations like this, anybody remember what it's called when you have two equations with the same two variables? Remember hearing that phrase? System of equations? Okay. Just a fancy way of saying you've got two equations with two variables, or three equations with three variables, or four equations with four variables. When you have systems of equations, what you want to do is you want to get all your variables on one side. So with the blue one, I've got 8x plus 4y, and I'm going to get the 8 on the other side, so it'll be 172 on the right-hand side. Okay. In the red one, I'm going to do the same thing, 10x plus 4y, and add 20 to both sides to get 200 on the right-hand side. Okay. Remember doing something like that? and then you drew a line underneath it, and you put a plus sign over here. And the hope was when you add straight down your columns, you should get a variable to cancel out or eliminate. Okay? It's called the elimination process. Okay? But if I add straight down right now, how many x's do I get? 18 x's. How many y's do I get? 8 y's. Well, that ain't even going to go away, right? Well, we're taught that you can take any one of these equations and manipulate them in any way that you want to, through multiplication or division. Usually you choose multiplication. So I'm going to say, let's go through and just multiply this top one, every single term by a negative 1. Okay? You multiply by anything you want to. -1, -2, -3, anything that you want to. But the goal is that you get coefficients of your variables to be additive inverses. They go to 0. They sum to 0. Okay? So I'm going to go down, add straight down, I get 2x. These are going to go away, right? And now what's -172 plus 200? 28. X then is 14, right? That makes sense? Same 14 we found over there in green. A lot more work here. Okay? And sometimes this work will be the only work we can do. So system equation will be important for us. But if there's alternative routes, maybe that alternative route is a little bit better. Now, if they want y as well, okay, don't I have to take the x that I found and substitute it back into one of these relationships here to find y? And I think if you do that, you get y to end up being 15. Okay? So I'll leave that up to you. But here's the idea. The original problem might have been find the measurement of that angle. Well, now that you know x, can you find that angle right there? And what is the relationship between those two angles then? Supplementary. So if I find x here was 14, 14 times 3, what's that, 142? Plus 8 is 50, okay? So that angle there is 50, so what's this one going to do?
130.
130, okay? Now you can check yourself, because if I plug x and y into here, if I found out that to be 130 up here, and I plug x and y in here, what should I get here? 130. So there's always some built-in checks. If you know the relationships about vertical angles, supplementary angles, complementary angles, congruent angles, that kind of stuff, when you're doing specific algebra, you should be able to have built-in checks. There is it's Math-Excel 2.6 Day 2. That's going to be open until Wednesday. The optional review is open until Wednesday at 8:15 a.m. And the 2.6 that I assigned on Friday is going to be due tomorrow during class. The test has been moved to Wednesday. Okay? A lot of people have a biology test tomorrow, so I moved it to Wednesday to help out with that. Yeah, I'm fixing it.
Okay.
You guys can go to lunch.
See you, Mr. Brad.